Here's a quick video to help you with the math part of finding pi in our Canvas, in our capstone project. So you've described, each of you, a target, which is the big shape, and then a bullseye that fits in it. One of the elements should be circular. In this case, we have a circular target with a zigzaggy triangular bullseye. And we're going to use the dots that hit both the target and the bullseye to give us a value of pi. Okay, so what I need to do is count all of the dots inside the circle and then count all of the dots inside my bullseye. All right, so if you look at this, I've pretended that I've counted 43 dots inside my bullseye and comparing that to the total of 78 dots inside the circle. This is not what is actually there. If you were to freeze the screen and count, it's different, but I'm just pretending this to be hypothetical. All right, now we're going to compare the dots that hit the bullseye over the total, because that's our definition of probability, the things we're interested in over the total things, all of the shots that hit the target, including the ones that hit the bullseye. We're going to do that and compare that to the theoretical area of the bullseye and the theoretical area of the target. All right, so we can save ourselves some time by not having to do a lot of math to find the area. We'll use the computer to do that, and I'm going to have the computer draw this polygon. If I draw this out and go all the way around the perimeter, I will get this shape. I have to go carefully all of the points as I go around it and get the area of this enclosed shape. All right, sometimes you'll have to break it down to be parts of circles and then parts of other shapes like triangles. But once I get that, now I can go to the area measurer right here and measure the area by clicking somewhere on the area. Don't click on the line, don't click on the point, click on an open area. And there it is. The area of this shape E is 151. Let's just compare. Oh, there it is. Sorry. I'm looking for all of the letters, so I'm not sure quite what I clicked on that confused it, but see how it's got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's how many points I clicked on. 163.58. Okay, so if I go back to this and type in the area as 163.58, I can then go back and measure the radius of my circle. Now, if it goes from 0 out to 22, oops, a little bit less than 22, I'm just, again, going to round it to make my life a little bit easier. The radius is going to be about 11, a little bit less than 11. But for illustration purposes, we're just going to use 11. So the total area of my round target, my circular target, is going to be found by pi r squared. That's the formula. You will all have your own unique formulas, but that's what you hopefully we're working on in class, and I gave you some help. And if you still are stuck, just come in ready to do that first thing in class. Once you get these theoretical measurements, we can now crunch the numbers. 11 squared is 121 times pi. I do not, repeat, do not put in 3.14. We want to solve for pi. We want to get down here and have pi by itself and be an answer. So I just need to put in this value right here. And now this is my simple proportion. I need to solve this for pi like it's my unknown x value. All I do is cross multiply. So there it is again. Okay, I'm going to have 78, whoops, I don't know why I deleted that, 78 times 163.58, and then that's going to be equal to 121 times pi times 43 when I cross multiply. Notice the equal sign didn't go away. I'm going to now do 78 times 163.58, 78 times 163.58 times 163.58, and you might have big numbers, you might have small numbers. 1275924, 1275924. So if I go back up here, that's going to be equal to 12795.54, I think. That's going to be equal to 121 times 43 pi. So again, just go back, bear with me on this. 121 times 43, 121 times 43 losing my calculator here. Okay, so that's 5203. So again, if I go back to this, that's equal to 5203, but then times pi. I have not lost pi. I hope I haven't lost pi. All right. Now, how do I get pi by itself? I just divide this big number here by 5203, and I'll divide it and I'll get rid of it over here. So what is that big number divided by 5203? 1279.5. So 1279.5.24 divided by 5203. Now, you are not going to expect this to be close to pi, all right? If you had more dots, it would be, but we're just using a limited number of shots. Let's see how close we came. Okay, 2.459. Not super close to pi, but it would be if I fired more and more and more and more of my dots at that target. Okay, so then in my report, I'm going to have that final solution, 2549. Okay, and I will compare that to the real thing, and I'll maybe talk about ways that I could make it more accurate. Okay, so good luck, everyone. Hope that helps a little bit. Crunch those numbers, solve for pi. Good luck.